Hello, hello. This is Postgres FM. I'm Nikolay and my co-host is Michael. Hi, Michael.
Hello, Nikolay.
And today we are talking about what? Corruption, right?
Yeah, absolutely. Database corruption.
Technical corruption.
Yeah.
No money involved unless you need to pay some consultants a lot of money to fix it, or at least to understand what's happening and how to escape from it. Because sometimes you cannot fix, you need just to escape and lose some data and save what you want and so on, right?
Yeah, these can be some pretty horrible stories, can't they? You see, every now and again, I see somebody mailing one of the mailing lists or popping up on one of the on Discord, on Slack, or something like that, and they say something along the lines of, "I'm getting this error message, help," and you can just tell, your heart sinks, and you think, "Oh, they're in trouble here. This could be bad."
Right. Let's start maybe from what corruption is. What definition do you have in your mind? Because I've heard various kinds of definition. What do you prefer?
Yeah, good point. I guess it's a few categories of issue. Like there's some things like on the subtler side, which are like incorrect information coming back for let's say for a query, all the way through to the database not starting, for example. Like maybe those are symptoms rather than the cause. Maybe the definition should. Well, you've probably got one written in front of you, but I guess it's data not being stored on disk in the way it was supposed to be. Something along those lines.
Yeah, well, we can distinguish particular type of corruption called data corruption. And in this case, that is quite broad, but I think it's quite good definition. You wrote something, you ask database to write something, you try to read it, and you cannot read it, or you read something else, and so on. It provides you, for example, you wrote 0, but when you read it, it's 1. This is corruption. But if you cannot read it and you have some error instead, on just no response at all, well, sometimes it can be called corruption, but sometimes if server is down, it's not corruption, it's down, right? Or it's not not working well at all and have some bug or something. Some people can name this corruption as well, but it probably doesn't involve any wrong data writes or data reads. Maybe just like server itself is not working properly. And data is fine on disk, for example. There's no real corruption there. But if we apply this quite broad definition, you wrote something, but you cannot read it or read something else, a lot of cases can be called corruption, but which are not really corruption. Right? So I'm struggling to find very good definition for corruption.
Well, I think there's it feels like we probably, if we got given 100 cases and we had to categorize them into corruption and not corruption, we'd probably agree on 98 or 99 of them. It feels like there's quite generally accepted cases. Should we go through some of the more common ones?
Yeah.
How do you want to do this?
Yeah, definitely. First of all, data corruption can be in heap, in tables. And for example, and it's quite common. It's not uncommon, because still a lot of databases have data checksums disabled, right? Because you need specifically enable them. This has overhead. Some managed Postgres providers enable them by default. Some don't. But if you install Postgres, if you installed it many years ago, it's hard to switch to data checksums on, because basically you need DB and dump restore, or you need to play some tricks, and we can discuss it with some extension. But it's not easy if you have a big database under load and the maintenance window is not welcome. You need it's hard. You postpone. I see many cases when people keep postponing this, living without data checksums enabled. So they probably have data corruption in table files easily. It can be also in toast files, which also part of data files.
Yeah.
Then it can be in various other places. For example, in indexes. And
Yeah.
let's discuss this in depth, like in detail, a little bit later. But now just let's walk around and see what else can be corrupted. Visibility map can be corrupted.
Yeah,
Right.
a bit more niche, that one, I guess. But the other major category, I've seen a lot, I've heard a lot of people that have had table data corrupted, indexes corrupted. It seems to be the most common one to me. And especially recently with the drama around version 14. But the other one that I see quite often is backup file corruption. And that catches people out.
Yes. And let's talk about this in detail as well. Now let's just collect ideas for our episode. And I also what can be corrupted? Wall files potentially can be corrupted, but fortunately for ages we have data checksum, wall record checksums enabled. Everyone has it enabled. It's there already. That's why we don't hear a lot about wall corruption. If you think also about levels, for example, data, you write something to table. Corruption might happen at software. It might also happen at lower software file system, for example. It might happen in hardware.
Mm-hmm.
So that we have also layers. We have verticals and we also have horizontal classification. It's like matrix. We can when we say data files corrupted. Well, but what if at protocol level something happened? You are writing 0, but protocol substituted to 1. You have data checksums enabled. I like it's crazy. It's probably not going to happen, but I'm just trying to explain about levels. So protocol replaced your value, right? And then Postgres wrote with data checksums enabled, everything is fine, checksum is fine, file system is fine, disks are fine, no corruption, right? But it already happened at upper level.
Yeah.
Right?
And you haven't even mentioned operating systems, I think, and that's like one of the major. Yeah, so there are so many places I get, and I guess
your application. If application took some value from user input and then replaced it, Postgres cannot notice it because it's already very upper level. But we won't be talking about application level. I mean, Postgres is also application. When I chose database as a topic for my bachelor and master degree, I thought my part of my university, which was like department, it was called Institute for System Programming, system programming. I thought databases it's in the heart of every system. It's very system programming. Later, I learned it's application programming, it's application development. Some people still say it's like system level, but database is still application as well. We won't be talking about upper level application. We'll be talking about application called Postgres, right?
Yeah, I think, as far as I'm concerned, I don't think if Postgres has been told to store a certain value and then it returns that same value, we're not talking about corruption. So if the application is to blame, I think that's out of the scope for me of the definition here. Cool.
Right.
Nice.
Also, replication, both logical and physical, might have issues, and it might spread some corruption. For example, of course, if some data is corrupted on the primary, it will be easily spread if you use physical. But interesting point here: if you use logical, probably you will be fine. It depends, of course. But
I was going to say you could have different corruption on each. Like they could be exactly the same. They could be different. All combinations seem to be possible. But yeah, really good point that logical can help avoid some of the types of corruption spreading. Makes sense. But equally, I've heard problems. Like I was reading up on a thread by a TripAdvisor thread a while back, where they I think it was actually replication that was part of the problem. It was replicating between two systems as part of an upgrade, but the replica was on a different operating system, and that ended up causing corruption. So I think this is the faint. It almost certainly was glibc related. I can't remember the details though.
Yeah, well, to finish with upper level one step back about upper level when application corruption happens. I remember I had a very weird case when my scripts based on pSQL returned one value, while application had different value from database, and application was Java. You know this meme, ground is Java, and all junior developers looking as goats, they are all on tree. So it was Java. It was a quite good customer, and they asked me like I trust pSQL much more, of course. Like what happens in Java with all those like Spring, everything, Hibernate, like a lot of stuff there. And like what's happening here? But then I noticed that in dbeaver, value is the same as in Java. And I think maybe we have an issue with pSQL, maybe some bug. But then I realized dbeaver also Java.
Yeah, good point.
So if you use JDBC
driver, yeah,
it has some like extra float digits or something. So numbers look differently sometimes, and you just need to change this, and you'll be fine. So this also kind of corruption to me, because like I expect one value, but it's really at upper level. The stored value was fine. pSQL showed it well, but at JDBC extra float digits. I don't remember the exact, as usual. I don't remember setting from top of my head, but this it's easy to find. But the thing is that JDBC and other drivers for Postgres, they work differently. And if this is, by the way, also to the question about UI versus console tools like pSQL. Console tools like better. Again, like JDBC can show you different number. You need to remember it and fix it when needed.
I wouldn't say console tools are better. I would say pSQL is better. Like, there's nothing special about console tools that mean they should. Did you see? But pSQL is very, very good software.
Yeah, it's called extra float digits. I just checked it, and default in Postgres is not the same as default in JDBC. And this is how you can easily get corruption. If you don't notice it, it's good that I noticed it. But if you write some application and your application does notice it, switching from JDBC and to other things like libpq and ODBC, for example, switching back and forth can cause corruption. If you read something and write to different place, to different table, you will have different results. It's corruption. Just causing by lack of knowledge about this setting.
Just realized we forgot to say that this was a listener request, and so thank you for that. And they mentioned they were interested in like what kind of types of corruption there are, how to detect it, how to fix it, how to safeguard from it, and even like are there any performance penalties to some of those safeguards? So that's an interesting question. I feel like we've probably, like, it's hard to carry on without talking about, well, they asked types of it. I think we've covered that a little bit, but it would be easier to keep going by talking about how can we detect it, or like, how do we generally find out about this kind of thing?
Yeah, let's dive into specific types of corruption. But to finalize this overview of types of corruption, I must admit that it's one of the topics when, like this saying, the more I learn, the more I understand that I don't know anything. This is corruption. It's the topic where you can easily realize that, this also can happen, this can happen, and then you already have feeling that there should be many more types of and kinds of corruption which we probably keep being unnoticed by everyone, right? But at some point we start talking about them. So we had a few sessions on Postgres TV also, including with Andrei Borodin. We probably should link them, where we discussed in detail various things. I will try to mention a few approaches. And also, I have a couple of documents where we try to summarize a lot of links, tools, and also mitigation issues, monitoring approaches, and so on. So where do you want to start? Heap, index, anything else?
Well, or even, as you said, some of those links could be useful. I was looking at the Postgres wiki. I thought it had a really good page on corruption.
It's good, but it's very, very limited. Mm-hmm.
I agree, but they make roughly the same point as you, which is almost by definition, a lot of cases of corruption are quite unique. If they happened all the time, hopefully there'd be things in place to mitigate them. So like the people designing software systems don't want this to happen. This is like, we spend quite a lot of episodes talking about things like performance, but performance doesn't matter at all if it's like this is quite a low level need. This is something people come to databases and really want. If you say, oh, our database is 1,000 times faster, has loads of other benefits, but there's like a 5% higher chance of corruption, or I don't even know how those numbers would work, but this is a really like basic need. This is something that Postgres, I think, has quite a good reputation on generally, but we still have some quite famous cases of issues. So, I thought it was a good starting point, that wiki article. I'll link it up as well. But you're right, it's not huge.
And when we talk about corruption, I always start also from that article. It's like it has some very core knowledge. And in the first lines, you will see. First rule, if you try to fix something, make a backup of your data directory or backups or what you have, like, because with trying to investigate and fix it, you are going to use some interesting risky tools and approaches. Some of them probably are not working well, and you may make harm additionally or just lose everything. So you need to start with additional backup of everything.
If you can copy everything and make notes of what you're changing. If you can't, there's two things though, right? Firstly, you can make things worse. Like you can end up in an unrecoverable state when you were in a recoverable state previously. And the second thing is, even if you do recover, if you don't have a copy of what it was like in a corrupted state, you might struggle to understand what the root cause was, or there might be some useful information in there for working out what caused this. And it also, I think it says quite early on, you might want to contact professionals for this. So most of us in our day-to-day work who aren't consultants, I count myself in this, don't see this often, if ever, in our careers. Hopefully, you'll never see this in your career. But consultants get called about this. I don't know, you could tell me the exact number, but probably at least monthly, like seeing different cases of this kind of thing. So there are people that have seen this dozens of times, if not hundreds of times in their career. So you might want to lean on their services, and it's probably worth it financially to pay somebody to help you with this.
It's one of the topics which for consultants like my team and I like to do, because this clients have fears. If you explain properly what kind of fears they should have, they easily have them, and of course they usually they're ready to invest into improving things. For example, improving monitoring and mitigation and so on. Let's start from backups. Probably, I find it as probably one of the easiest place. Backups without proper testing are backups like Schrödinger backups, right? Because nobody knows if they are working, and of course, all backups should be tested. Of course, it requires some resources. You need to provision virtual machines, for example, and test them and so on. You need to test recovery from a backup. And usually it means usually backups, incremental physical backups, they have full backup plus maybe delta backups, and also whole stream of 16 or 64 megabyte walls. So when we test, we need to test full backups, delta backups, and also we need to test all walls and point-in-time recovery until the very last point before next backup started. So it's a lot actually to test, because otherwise probably full backups is working, but later in the day, for example, you have daily backups. and you test full backup is working, but then some wall is missing, for example, or corrupted or something. Well, wall corruption might be something which won't happen as we discussed, but the backup tool compressing walls with some innovative compression might cause corruption of, like, you cannot restore it, for example, and a full backup test passed, but some wall later, if you don't test all walls, whole stream for until next full backup, you probably also won't be able to restore until some point, until the latest point. Usually, we need to. Yeah.
In my experience, larger companies tend to have this down. They tend to have a process for doing this on a semi-regular basis, if not very regular basis. It's somebody's job to do the full run of this every couple of weeks or every couple of months, depending on how serious.
Every day, it should be the same frequency as backup creation.
Oh, you think?
I'm sure.
Oh, if you automate it, so you're talking about an automated.
Everyone
process.
must automate it, otherwise backup system is super weak. That's what when people say untested backups are not backups. This is it. You need to test all backups. Of course, you need to pay for it, unfortunately.
Yeah.
And all walls, including all walls.
But a lot of people, I think there's a lot of, especially smaller companies, startups, that either have never tested a backup or did it once as like a one-off, like
Or they just trust RDS and that's it.
Exactly.
Or
that's another point.
Yeah.
That's another good point about only having backups in one place, right? Like,
but how can we be sure that RDS tests all backups properly,
or that they're not corrupt, right? To the point of, like, to the topic of today. How do you know they're not being stored in a way that's accidentally?
Oh, by the way, when you restore, like, there are also some levels. First, you restore and can reach a recovery point, and Postgres is working, like accepting connections queries, right? But then you usually we think, okay, what about data in this restored Postgres? Maybe something wrong, right? Maybe corruption from production propagated to backup. And here we usually, like, very simple trick, you need to dump it fully to dev null, causing reads of all data files, but not indexes, by the way, right? And dumping, it's like, it sounds silly probably, but this is a very good approach, just to cause reading of all files. It might take a long time. While this, you need to pay cloud for these resources. Resource consumption is significant here, but this is the only option to test backup and see it definitely works, right? So backup recovery works, point-in-time recovery to any point in the day works, and we can read data. But reading data, it's already verification of data files, not backups, not recovery itself, not restoration process. Right, it's already beyond backups, but this is a good place. If you have a backup verification automation, at least some, like, maybe not every time, but sometimes this is a good point where you can start testing various things, including data corruption risks and index corruption risks as well.
Yeah.
And also worth mentioning, some, like, larger companies you mentioned, they have some additional replica. For example, it might be delayed replica, used sometimes to quickly recover accidentally, mistakenly deleted records in database. So they have, for example, a replica which lags some hours, like 6 hours or 4 hours, always behind. And this replica usually, of course, it's based on wall shipping, and this replica can be considered as a test tool for wall stream. You still need to test recovery of full backups, but walls are tested by this replica. Or you can install database lab engine, and it will be reading for walls, and also if it's down, there is a problem with walls. Also a tool. So it's a complex system to test backups.
Yeah, so, that sounds good, and it's a really good point that these can be corrupted, and the best way to check is see if you can restore it. That's
S3 can,
if you
can have problems as well. Like,
yeah, of
usually
course.
no.
But then we're back to the other topics, right? Then we're back to heap corruption, index corruption, and maybe that's the main thing. I've read a few times that Amcheck, whilst it does only check B-tree corruption at the moment, it is a great tool for as like a smoke test. If you run Amcheck and you get any hits, then you've got a problem. So it's quite a nice and quite fast way of checking, I believe.
No. In
Go
short,
on.
no. Okay, let me finish. I said S3 can be corrupted. So S3 to store backups in object storage is very good because S3 or GCS, they have very reliable storage, so they don't lose data. But uptime might be worse than EBS volumes, for example. So when you test it, you need to understand that sometimes it's slightly down, but they won't lose your data. This is a very good thing. Okay. So some retries logic needs to be implemented. It's a whole project to test backups properly. But okay, let's shift to data checksums probably, and then talk about indexes, because I think these topics are narrower. So data checksums should be enabled. Of course, there is some penalty overhead, you need to pay for it, but in my opinion, they should be enabled everywhere.
And which version was it? Like 10 or something, 10 or 11, something around there.
It's an option for initDB, and in my opinion, it's still disabled by default.
I think so,
No?
but I think I was only introduced. Like it was introduced in my memory of working with Postgres, I think. So I'm thinking like 10 or 11.
I don't remember. In all currently supported versions,
I think
they
it is
are
available.
available.
Yeah.
Right, but there is also PG checksums, which it has as I remember, all new versions they have it in it's a contrib module, right? It's PG checksums. And it helps you enable checksums, and there is a recipe, so you can do it on replica first, then perform switchover, and then cover all existing replicas. So, with very small downtime, close to zero, it's possible. But for older versions, this tool, PG checksums, didn't exist. But there is a third party, I don't remember. It's not from Cybertech. It's from maybe from Cybertech. I don't remember exactly. But this tool is available for all the Postgres versions, like 11, 12, I don't remember exactly. And it's also possible to use it with replication, switchover, and achieving downtime close to zero.
Do you know what that one's called?
Also PG checksums, no?
Oh, okay, cool. Makes sense.
Maybe.
I'll find it and link it up. I wasn't aware of that.
Yeah, so they both called similarly, maybe some difference. I don't remember in detail. But this is it. You need to enable data checksums, and that's it. It still doesn't mean, for example, some constraints can be violated silently. Data checksums won't save you from this. It's like upper level corruption. Data checksums will save you from having wrong writes. So you wrote something, disk for example corrupted, file system has bugs, and then you read something else or cannot read it at all. This is where data checksums are needed. Also, you need to choose either to how there's a setting saying that you need to stop if corruption was detected, or you can continue but just have some errors in logs. Of course, usually, it's interesting. I had very interesting discussions with very experienced people who have good experience with Oracle and SQL Server, and we discussed what is better for current business. For example, you have e-commerce, which generates $1,000 per minute, for example, or per second. And you have corruption, and you have very good, strong tool, and you enabled it, and it puts your server down if corruption is detected, saying, "Oh, corruption, fire!" Right? Of course, you'd prefer to continue, and if corruption is limited,
Yep.
you don't want to be down at all, right? So it's better to know about it, mitigate somehow, but you want to continue operating. This is interesting, right? And we also mentioned that some, like SQL Server, they have interesting approach when corruption is found on one node, it can auto-heal getting not corrupted files from replicas, for example, from standby nodes, bringing them
Interesting.
back.
Yeah,
Let's auto-heal. Postgres does have it, but it's an interesting idea. And but like rule of thumb here, enable data checksums. If you don't have them enabled, use this extension to enable. So indexes. Let's talk about indexes.
Yeah.
Uncheck is it's a good tool, a very good tool.
Is it worth quickly covering like what? So B-tree index specifically, why do we tend to see more index corruption than heap corruption?
Because of collation and glibc version changes. For example, if you upgrade from one Linux, for example Ubuntu, to another, there's an article which said like glibc version 2.27. I don't remember, 27 maybe. Has dangerous changes, so you definitely need to be careful. And it said other versions are fine, but in my practice, I have zero trust. If we plan OS upgrade, if we plan any upgrade of underlying software, glibc, and you can check version LDD-- version, you can check version. If we expect this version will change, or if we also play with containers, you might have some binaries in container which if you have container with Postgres and pgdata is outside of container, probably pgdata was created using different glibc version, and in container you have different, like if there is mismatch here, what can happen? B-tree is built using one order of characters, collation, right? And now we have different order. And you can just, for example, not being able to find some, like you select something and previously you had some rows returned, but now you don't have them at all. And we can distinguish two types of problems here. One is read problems, and another one is propagation of read problems to writes, which hurts more, because it's permanent.
Yeah, so examples of a read problem.
Customers cannot find, they search something and cannot find something.
Or they get back incorrect data, right? Like they get back data they're not expecting. So that's like often how these present themselves. Or as you said, like the write problem, if we can end up with duplicates, like we can end up looking for an identifier, it doesn't exist, so we insert another one, and we don't think it exists because we're looking up like via the B-tree lookup.
Duplicates is a slightly different problem, not related to the order of or glibc version, but it also can happen. Duplicates is a different problem. Because
I think it could be related to, because it's like, isn't it using like the primary key lookup, like, because isn't it using the B-tree for the unique constraint checks?
Right, but if order changed, the uniqueness is not violated. The problem is you probably, we just changed the order of columns in order by. This is a key problem.
Cool. Well, my understanding is you can also end up with like data being in the wrong partition, for example. Like, so ordering affects quite a few things.
Corruption. Yes.
So I was thinking the index is used for those things, but no.
So uniqueness violation might happen, and user actions might cause it sometimes. But I don't see how the order, like how we order characters can lead to it. Maybe I'm wrong. Maybe I just don't see it. But what can happen, in my practice, I saw it, like what can happen, wrong order, so user expect one order, having different order, and missing results completely because of some ordering and limits. Results are out of scope, and this like unexpected, and so on. And bigger problem is indeed writes, and if it's some billing subsystem, you can propagate wrong writes. Some people can not get money, for example, right?
Yeah. I was just thinking, when you gave your e-commerce example, I was wondering what the trade-off would be for, like, let's say a bank. But if you're worried about people's like balances being wrong, for example, is that a different matter? But I still think they'd make the trade-off of keeping it up and dealing with the consequences in a lot of cases. So it's an interesting question, like which applications would choose which.
Yeah. But anyway, OS upgrades are dangerous, right? And containers are slightly dangerous. If you bring PG data, we had it also. You bring PG data from different operational system, and you run your Postgres in container. Well, even without containers, if you just copy PG data between two nodes, and one node is running Ubuntu 16.04 and another is 22.04, you are going to get a trouble because you copy at physical level in this case. You need to copy at logical, dump restore. This is where dump restore plays good. Yeah. Because it eliminates the problem completely.
And I'm not sure we've said it explicitly since we switched to talking about indexes, but the tool for checking B-tree index corruption is
right.
still
AMCheck. Right. AMCheck, right? And you mentioned it's lightweight. It has several modes, and unfortunately, the proper way to check it is heavy, and you shouldn't do it on production because it requires exclusive lock. This is where you probably need to put it to backups verification system. And after you restore, you run it on all indexes. It will take a lot of time, but you needed to run it using special snippet, which like parent, blah, blah, I don't remember, but it also checks relationship between leaf nodes, and this is where order can be easily broken. So you need this, and it will take time. And funny thing from practice that if you do it at SQL level, it's single-threaded. But it's not fun. If you have a lot of indexes and you have a lot of cores, you usually, there is trade-off. It's with backup verification, same trade-off. If it's in cloud, you usually think, okay, I will hire much more powerful machine, but for shorter time. And I will do job much faster and destroy it. So budgeting here, it's interesting for such kind of verification projects. But if you do AMCheck, don't do it in single thread. Do it utilizing all cores and disks, like saturating them, because it's a verification machine. We should go full speed. Nobody's there, right? If it's so, of course. But then I twice wrote parallelization scripts for it, and only then realized that since Postgres 12 or 13, maybe 13, there is a CLI tool, pgMustard, which has -j. -j is for parallelization. So and you can use it for older Postgres as well. Because
yes, that's a really good point. I think you brought this up. I think we had an episode on index maintenance, right. And so we've actually covered AMCheck and this stuff in quite a lot of detail for people that want to go back to that one. I'll link that one up in the show.
But it's covered even more with our sessions with Andrei Borodin, and in documents I mentioned. We will definitely link to this episode of these documents, and we have table for monitoring and prevention mitigation measures. So, yeah. So, and AMCheck, we see patches to check uniqueness violation. There is such patch, but it's not committed yet. It's ready for committer, and unfortunately, it won't be in Postgres 16 because it's already almost beta. Next week we have beta, right? Beta 1. And,
so we've gone past the feature freeze for Postgres 16, right?
Right. But I hope it will make it into Postgres 17. And I think it's one of the good cases when you can start using it before official release and also help testing it. Because on these verification machines, temporary machines where you verify your backups, probably you can run like not polished software and so on.
It's a good point. And what's the worst that, like, I guess if it's got bugs, like that's the normal reason to not use it, right? Is it could
there are
be buggy,
false positives and false negatives. False negatives, like you miss some problem. Well, without using it, you miss it for sure if it happens. Yeah. So still unpolished software is still beneficial. False positives are annoying. Like it says, like uniqueness violation. I mean, you can take patch, apply it to AMCheck, and use it in this non-production machine on a clone. It says, uniqueness violation. Okay, it's easy to check and verify.
Yeah, exactly.
Right.
So it's quite a nice failure case.
For corruption, slightly more complex, of course. For example, it says, there is corruption index. Well, in this case, you can just rebuild it on this machine, this very machine. You rebuild it and check again. If it still says corruption in the same place, probably it's false positive. Because you fixed it already. Rebuilding fixes it.
Yes, so that's I guess where we should be going is how do you fix some of these issues? And with indexing, it's relative, or with B-tree indexes, because it's an ordering issue. Yeah, normally, right? Re-indexing should fix the ordering because you're re-indexing with the new collation. So it's that's the fix. And as you say, if it shows again, it'll be a false positive. Although I guess that would then mean it's a bug in amcheck, right? Yeah, of course.
Yeah, and worth mentioning again, Postgres versions 14.0.1.2.3 are super bad because if you use create index, reindex concurrently, you might have corruption. And in this case, if you use the same version on this verification machine and amcheck says corruption, you rebuild it with concurrently again, probably it says corruption again, not good. So like in this case, for like concurrently has concurrently option in create index and reindex is super cool, but it has long trail of bugs, unfortunately. And if we run amcheck on this clone, non-production, I would verify all findings with regular reindex.
That's a good shout.
Which is more reliable.
Because you don't have people reading, right? Like you're not worried about the locks.
Single user machine, right?
It's faster too, right?
In this case, even if I was running 14.0 and corruption came from production because of the use of concurrently option, here I would amcheck find it. I run reindex and amcheck shouldn't find it anymore. It means it's not false positive, right? We go.
Good point.
But amcheck for bitrate is quite reliable. It shouldn't produce false positives. Like it's quite broadly used and well tested and production tested. Amcheck with this patch for uniqueness violation, of course, different story. And also amcheck with patch, which also the same, like it's ready for committer, but not won't happen in Postgres 16, unfortunately. Amcheck for gist and gin indexes. Long-awaited thing. It's very also needed. Andrei Bardin also participated in this. And this patch, I tested myself, I applied it to amcheck and started to test. I saw false positives. And I was told that there were many false positives in the beginning, but a lot of them were fixed already. So it has many iterations already. So I would consider this quite good. And I encourage people to try it in non-production. You still need non-production because of this exclusive log. Andrei mentioned some improvements for future Postgres that will probably make possible to run amcheck in production in a less aggressive way. But currently, I prefer amchecking on the clone, where I can do more things and so on, utilize the whole cores, saturate disks, and so on. It's better. So that's probably it with amcheck. Mm-hmm. Again, I'm looking forward to having gist and gin support and also uniqueness violation support in future versions of amcheck, but we can already start using them, taking just patches, right? What else? The visibility map, there is also some tool to check visibility map corruption, because it's not good to have it as well, right? If it happens.
Conscious of time, I think. Yeah. I think there's this episode could easily be like 3 hours long. I suspect we could go on for a long time.
Yeah,
but there's a few good posts that I wanted to mention. So I think
mention my document. It has a lot of links. Yeah. I must admit I didn't send it beforehand, but it has lots of information. If you find something it's missing, let me know. I will put it. I'm trying to collect everything about corruption, and it's a very broad topic. It has many directions, and
Did you see the one
areas.
by? So nice. I look forward to reading that. There's one by Cybertech that's quite a fun post of Lawrence, I believe, going through about giving quite a few examples of ways to corrupt the database, which is quite a nice way of learning the kinds of things you can do to end up Go on.
how to corrupt how to corrupt. It's interesting area of DBA practice. Let's corrupt to learn.
Yeah.
And I mentioned I remember something like corruption related to XID wraparound. Is it this topic? Is this post or no? Transaction ID wraparound.
Sorry.
Or something else.
I can't remember that one, sorry.
It's okay. Yeah, it's okay. So how to corrupt? I remember it. I have it in my list. Yeah, it's a good. There are two posts on Cybertech about corruption. One about XID wraparound, and another is just about corruption. There's also interesting tool Noisia from Alexey Lisovsky. It's like how to damage your Postgres. A tool just to learn and practice how to escape from various situations, right? We didn't cover cases when you have corruption, how to do it. Like, of course, PG reset wall is a tool.
Yeah.
It will take time, and you definitely need to back up before. I use it several times in my practice. One case was interesting when Postgres was running on top of NFS in AWS and got corrupted. But fortunately, only one table was corrupted. It was PG statistic. So it was super easy to fix. Just analyze whole database. It's rebuilt. No reset, just analyze. Yeah, but to find the proper, like what's corrupted, it took time, like half an hour at least, and it was nervous because it was under pressure from clients. So yeah, and I remember like some cases takes hours or day to fix and to escape with some data losses. So it's a huge topic.
There's one more final thing I wanted to mention. There's a good presentation. I think it was quite an old one from Christofides that the slides are available online. I'll check and see if I can find the talk as well. But I thought the slides alone were very good. And that was detailing a previous case. So you talked about the 14.0 index and reindex concurrently corruption issue. There was also apparently one that I wasn't aware of back in 9.3.1. So even in a minor release, there was a case.
Let me mention a few names as well. I mentioned Andrei Borodin, a lot of work related to AMCheck indexes and so on. Of course, Peter Gagan and tools work in B3 indexes and so on, and also a tool called PG Hexedit. I use it a few times. You need Linux for it, but it's still like very good thing. And on top of pgInspect, visualize B3s and other types of indexes as well. Let me mention also Robert Haas has a few talks about corruption, but I find them quite basic, honestly. Like they are like, this material is definitely solid and core, but there are many things missing in those talks. Also, of course, work mentioned Cybertech posts always great. Thomas Wondra, PG check, PG cut check from Enterprise DB, by the way, interesting thing. What else?
What was it called?
PG cut check, catalog check. I think it's about, I'm not sure it could be applied to regular Postgres, but the catalog checker to find corruption in system catalogs. It's also interesting topic, worth exploring as well. PG toolkit by Bertrand Druvo, sorry, pronunciation wrong, but also there is a PG toolkit, or also works by Jeremy Schneider, good posts and talks as well and so on. Interesting materials by Jeremy Schneider from AWS team. Well, yeah, a lot of stuff. So
wonderful. And if people can only take one thing away from this, what should they? Maybe they should restore, check their backups. What would your number one advice be?
Check backups with Wallstream. Dump it to def null, causing reads of data, but not indexes, because when you dump, indexes are dumped like a create index. We don't know content of indexes, right? So add AMCheck for B3. Heavy one. We have snippets with parent function. And then if you want to go further, of course, enable checksums, right? Enable data checksums. If you want to go further, use visibility map checks on production. Also use patched check to verify gist engine if you have any in non-production after backup restoration, and also uniqueness violation, and many more tools like I mentioned with pgcat check and so on and so on and so on. It's a rabbit hole.
One more thing: read release notes even for minor version releases, because if there were any Postgres bugs causing issues like this, they will be mentioned in there with mitigation steps. Sorry, I completely forgot that one.
Right.
Nice.
Right.
I think we're done.
I didn't mention many good names as well. Sorry, it's a big list. PG checksums, it's from Creditive, and it went to Postgres core in Postgres 12.
Very cool.
Yeah.
Well,
good.
If Nikolay forgot to mention anybody, it's a definite case of corruption. He's just mentioned all his friends. That's it.
No, if I got to mention something, I mentioned it. It just was not recorded.
Oh yeah, good one. Blame the internet connection.
Recording corruption. Right.
Yeah. Oh yeah, I like that. Yeah.
So
nice.
if you have more ideas, please tell us on Twitter, LinkedIn, and comments, YouTube, anywhere, and help me collect. This is community effort. I like 99% of what is there. It's not from me. I am like a hub, and these documents are quite good. Like if you take any of this document, you can find work for any DBA for a year at least in serious projects. Definitely for a year. Like a lot of stuff.
Last bad joke from me for today. Would you consider your work a collation?
Okay.
It's time. Thanks, everybody.
Good ending point, right.
Catch you next week.
Let's call it a day. Have
Bye.
a good... Yeah, bye.